High up in the Bolivian Andes is Puma Punku, an ancient site carved to such perfection that engineers today confess that it should not be. Over 100-ton blocks are cut with flawless 90-degree angles, yet history records the builders used stone hammers and bronze chisels more than 1,500 years ago. For generations, experts have argued over how it was achieved, or if we're even asking the right questions. So, researchers did something no one had tried before. They fed every known scan, photograph, and measurement of Puma Punku, over 12 terabytes of data, into a cutting-edge artificial intelligence. The results shocked even the skeptics. Because not only did the AI rebuild the site, it uncovered something much more sinister lurking in its architecture. If this kind of story touches your heart, if you're someone who cares about truth, responsibility, and speaking up for the voiceless, please like this video, subscribe to our channel Spark Science, and share it with someone who should hear it. Let's get started. So you can grasp why researchers are so shaken by what the AI reconstruction revealed, you first must grasp just how puzzling Puma Punku already was prior to technology being introduced. Situated on Bolivia's high-altitude Altiplano, a windswept, frigid plateau perched more than 12,000 feet above sea level, Puma Punku has stumped experts for centuries. It's not another Incan ruin. It's a place so sophisticated that even veteran archaeologists concede it shouldn't have been possible for the folks who supposedly constructed it more than 1,500 years ago. Let's begin with the simplest question: what is this place constructed of? The complex is built primarily with two varieties of stone, a less hard reddish sandstone and much harder volcanic stone known as andesite, with a hardness level of approximately 6 on the Mohs scale. That's only one step below quartz. In the books, the Tiwanaku culture that allegedly constructed Puma Punku is described as having stone mallets and primitive bronze tools at best. Attempting to sculpt andesite with technology like that is not only hard, it's ridiculous. And yet, somehow, they didn't just sculpt it, they engineered it. The stones are enormous. The biggest one is an estimated 131 metric tons, trying to move almost 70 full-sized family sedans piled on top of each other. Most theories suggest these blocks were pulled using wooden rollers. But there's a catch: the site is way up above the tree line where nearly nothing will grow. What that means is timber would have had to be cut in the verdant valleys far, far below, then hauled uphill over hostile terrain just to begin rolling these rocks. To do that dozens, perhaps hundreds, of times. Now, suddenly, the simple solution doesn't seem so simple anymore. And then there's the precision. Forget rough-cut ancient mason work, the stones at Puma Punku look machined. Many are cut at perfect 90-degree angles with surfaces so smooth they reflect light. The famous H-blocks are the most astounding, identical andesite pieces carved with complex internal right angles, recessed reliefs, T-shaped slots, and grooves that look closer to factory-manufactured parts than anything you'd expect from a pre-industrial society. Put them side by side and you see they were designed to fit together, like giant slabs of stone Lego. Some even have drainage channels where molten eye-shaped clamps of bronze were poured in to join the stones together, indicating an appreciation of metallurgical methods of casting not believed to have existed here during this period. True, it's not precisely accurate to say that a razor blade can no longer fit between the stones. Earthquakes and millenniums of weather have cracked and moved them. But many of them still align almost with incredible precision. So the questions accumulate: where did they learn the engineering? What tools did they use to make it so precise? How did they transport stones that weighed more than a blue whale over harsh landscapes? The reality is that conventional explanations for Puma Punku had systematically been breaking down for decades. The conventional account runs like this: Tiwanaku builders, with stone hammers and bronze chisels, tapped into the very hard andesite stones painstakingly. Then they allegedly finished smoothing out the surfaces by rubbing them with sand, water, and countless hours of labor. In laboratory experiments, scientists have demonstrated that this can be made to work, if you're cutting one small block. The issue arises when you take a step back. It's not the same thing to know you can cut one flawless 90-degree corner as it is to describe how many hundreds of tons of those stones, repeating, uniform, and interlocking, were cut and built over more than 1,500 years. The pace of the primitive technique just can't compare to the gigantic scale, consistency, and standardized layout observed throughout Puma Punku. Either they had a labor force so huge it would compare to construction teams today. Or there is some hole in the story. That void left the door open for alternative explanations, some intriguing, others fringe. One rising idea is the liquid stone or geopolymer theory, which claims Tiwanaku engineers didn't carve these stones at all. Instead, they supposedly knew a chemical process that let them dissolve andesite into a slurry, then pour it into molds like ancient concrete. This might explain the sharp angles and H-shaped blocks. If it were true. But most geologists reject this resoundingly. The mineralogical signatures in the rocks bear no evidence of reformation. These are natural, quarried stone blocks. So the argument was mired between a conventional explanation that many thought was too anemic, and outsider theories most thought were too fantastic. That's when a different tack was developed, one that didn't rest on what we believe they might or might not have done. In its place, an international team of scientists initiated something they termed the Altiplano Project, a brave endeavor to have the evidence do the talking. University teams from Bolivia, Germany, Japan, and the United States spent 5 years gathering every bit of quantifiable data they could. They applied high-resolution laser scanning to map more than 150 individual stones to the micron. They used ground-penetrating radar to search for buried architecture. They looked at chemical traces of metal left on clamp points. They engaged satellite images to attempt to follow lost quarry paths. Astronomers even tested if Puma Punku lined up with star systems as part of a celestial blueprint. Collectively, they amassed more than 12 terabytes of raw data, a digital time capsule sealed within stone. This is when the technology came in. Rather than instructing the AI on what to look for, they instructed it to reverse engineer the site. No theories beforehand. No human bias. Simply take the data, angles, alignments, tool marks, composition, and attempt to reconstruct Puma Punku in the most logical fashion possible. The objective was straightforward: if there was a system at work here, a design language, a workflow, an ulterior motive, perhaps a machine would spot what the human eye had overlooked. When the artificial intelligence began its analysis, it didn't worry about reputation, ancient myths, or long-standing academic hypotheses. It didn't look at stones, it looked at data. Vectors, chemical signatures, mathematical proportions, even celestial latitudes. Out of that digital mess, something incredible emerged. For the first time in history, Puma Punku rebuilt itself. For centuries, archaeologists have strolled among fallen walls and broken megaliths, making educated guesses about what the original buildings may have appeared like. Guessing, however, is subjective. The AI did not share the same issue. By comparing thousands of tool marks and matching fractured pieces such as pieces of the world's most challenging jigsaw puzzle, it computer-solved everything back together. What was revealed was not an ordinary courtyard or temple. Puma Punku was once a giant, multi-level architectural wonder, says the model. It had a raised platform mound, a few interior chambers, gateways linked by corridors, and a sophisticated system of channels. Certain channels, it discovered, were incised with such accuracy that water would have coursed through them at measurable rates, creating big shallow pools. Placed just so, those pools would have reflected the night sky, implying ritual observations of the heavens with water as a megamirror. But that was just the tip of the iceberg. The most astounding thing the AI revealed wasn't about looks. It was about process. Puma Punku wasn't built stone by stone in some kind of wild, tribal way, it was made. Similar to a contemporary automobile factory, the location relied on interchangeable, modular parts. It discovered that 45 of the celebrated andesite H blocks were cut from a solitary master model. The positioning of grooves, angles, and recesses was mathematically consistent within thousandths of an inch. That meant standardization, nearly as if on an assembly line of a factory. The AI proceeded to find a central group of about 19 distinct types of blocks, which recurred throughout the whole site. Put together in various configurations, these building blocks created walls, gateways, terraces, water infrastructure, everything. That is, Puma Punku was not haphazard masonry, it was a colossal construction set created centuries prior to the concept of prefabrication even being a thing. After it reassembled the complex in three-dimensional space, the AI began to run mathematical analysis throughout the site. That's when it discovered another level, geometry. Repeatedly, the site uncovered extremely specific proportions, ratios such as 1:1.618, more commonly referred to as the golden ratio, well known as a mathematical definition of beauty and harmony. The AI followed that ratio in doorway heights, slab widths, and even in gateways distances from each other. It came to light, the constructors did not merely desire the